Well, this is chapter 10. And you could have predicted that this is going to try to put everything all together, which it does, which is very good if you're preparing for the comprehensive final. It also deals with the field of learning, sort of beginning when I was in it and continuing thereafter. So a synthetic perspective on instrumental action, and talks about a behavioral analytic approach that was covered back in chapter 7. The synthetic approach draws on materials covered in 7, but also 8 and 9, as well as material throughout the rest of the book. And it can be seen as cognitive. And as I mentioned, Skinner was anti-cognitive. He had a big battle with cognitive, and cognitive won. And that's where this book is taking us. So the earlier parts of this chapter, I have some strength in because my research overlaps, or my historical research overlapped with some of this. Toward the end of the chapter, it gets not philosophical, but more integrative. And the best way to deal with that is to look back at the other chapters and read this chapter carefully. So here we go. Avoidance learning. I'm very happy to deal with that. And this overlaps with sort of where I came into the field. You'll remember positive and negative reinforcement. And this is classic negative reinforcement. The behavior removes the stimulus from the environment. Of course, when you define positive and negative, which you certainly will be on the comprehensive final, don't forget the contingency part of this. So there's a shuttle box. I don't think I've ever used a shuttle box that simple, but it certainly has been used quite a bit, and well before 1985. So you have two chambers, and these are the shock grids that are connected to a shock scrambler. The polarity changes and the animal stands on them, so it can't avoid being shocked. You can shock on either side, but in the simplest situation, you associate the shock with this side, and then the animal pushes through this little door and ends up on this side, and they don't get shocked over there. So that would be a one-way shuttle. That is, you go in only one way, from left to right. You could use this device for a two-way shuttle, where after being safe on the right side for a while, you're threatened with shock over there, and you have to go back to the other side. And start thinking about evolution. In this chapter, Bowles will show up, and his views of behavior are important. And Bowles was important to the author of this textbook, and also some researchers that I overlapped with. Not Maurer, but two-factor theory. He's back in the days of Skinner, 30s and early 40s. And there's a discussion there with a little graphic. You have Pavlovian fear conditioning with a stimulus associated with shock. And you can reward behavior. If you respond appropriately, the threat of shock goes away, and that reduces fear. So that's a nice theory. As we'll see, it's not quite that simple, but uh, it's still important and relevant. And broad implications, learning whether, when the buzzer goes off, affects the ease with which the animals will learn this. And Neil Miller, I was a huge fan of his, got to shake his hand once. He's he did a lot of things in choir, including the research reviewed here. And notice that you've got black and white compartments. Animals usually like the dark side, so the light side is sometimes systematically associated with shock to really make it aversive. And sometimes there are textures and smells that can be associated with that too. Notice finally the rats learn to press a lever to open a door instead of turning a wheel. The animals are more willing to turn wheels. I have a photograph of an operant situation where they dig and they're willing to reach out and spin the wheel. And once they learn that behavior, you can shape them over to lever pressing, which they are much less willing to do. And again, think about evolution, and you'll see bulls and important stuff relevant to that. And there's a discussion of different situations in which fear may be important for maintaining behaviors. And bulimia nervosa, that's a bad one. Fear of getting heavier. People with bulimia eat and then force the extinction of anxiety by preventing them from vomiting. Response prevention, and this can be helpful. So this chapter in general, well, the whole book is relevant to clinical treatments. And if you're going into therapy, this is a very, very important book. Book course. So problems with the two-factor theory, there are some, as it points out. The fear and correlation with the strength, it depends on how well trained you are, as we'll see. Kamen's name comes up here a lot. And condition suppression is back. Remember the 0.5 number. So you always have to look at your y-axis when you look at these figures. And that's a beautiful little figure. So you have, the CS that is associated with shock, and you have different avoidance criteria: 1 response, 3 response, 9 response, and 27 response. And what's interesting is if 1 response does it, you don't get much suppression. 3 more suppression, 9 more suppression. So you would think 27 would give you a crazy amount of suppression, but no. In fact, they're a little bit above 0.5. So they've got it. They know what they're doing, and they do it, but they're not crazy fearful during the time that they're uh, emitting a well practice uh, uh, escape response or avoidance response. Um, so there's behavior analytics, Skinnerian tradition. Uh, they don't like theoretical constructs. They don't like the concept of fear, but they still sort of went down this path. And Sidman is important to me. And here and I've done this one. Um, the Sidman avoidance, like the Morris water maze, like the Cayman blocking effect. I liked the human name associated with it, and the book breaks down and does it here. Sidman avoidance, and here's a nice figure and you should be able to define these concepts. So on the top you have when the shock is delivered, and there's the shock interval, which is typically a fixed interval, uh, not in the sense of fixed interval partial reinforcement schedule. It's just fixed. So there's, shock, 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 and then, there's a big interval without shock, but it's not labeled. And that's because that's labeled down in the response line. So that's the response shock interval. And you can see, as is typically the case, not always, but typically, the response shock interval is much longer than the shock interval. So the animal gets one big window of no shocks, but then it comes out of the response shock interval and gets a shock, and then it starts getting the picture and does better. This isn't easy for animals to learn, particularly if you ask them to do something relatively unnatural like press a lever. Other behaviors are easy to learn about. So response outcome is important to this chapter. Everything's important in this chapter. So you have to have an open mind. You have to be thankful that this chapter is happening because we have a comprehensive final. And, go back and look at this. So this is sometimes called unsignaled avoidance because there's no lights or other stimuli associated with this. But as is pointed out, that time can be a stimulus, and time passing could be a cue telling the animal it's time to respond. Herrnstein, very, very important research. We've seen him before, and he's talking about the responding, reducing the rate of shock, and he has done some clever research. And the Herrnstein and Heinlein, 1966, the idea of average response shock rates going down being important. That's important. And Cayman we've seen before, and here's Bowles. One especially interesting set of experiments was done in the laboratory of Bowles, and which includes this author and some other people in this chapter. And I've done some of this too. I became interested in this, not thinking too much about evolution, but I liked Bowles's work. And we had a running wheel in the lab, and we had photocells, and I put little flags on it, and I could record when the running wheel had moved a quarter turn, very much like this. And start thinking about shuttle boxes, one-way shuttle boxes, two-way shuttle boxes, lever pressing, spinning wheels, being in a running wheel. Which of these is more natural, more in line with the animal's evolutionary history? And there's some beautiful bulls data from right around when I went to graduate school. So higher numbers here are better numbers. Shuttlebox does shuttling turn off the light or not turn off the light, and how many responses do you get? And you can see that if the light, I'm saying light, it could be a light, it's a stimulus. The very, very strong winner is the upper left-hand quadrant, where shuttling does turn off the light, and the other ones are much weaker, particularly the bottom right. But in the running wheel, the pattern is in the ballpark, but oh geez, you get much better behavior out of the animals in the running wheel. It's particularly notable how well they do in the no signal terminate warning condition. It's almost as good as the signal is terminated. And that lower right-hand box that was abysmal for the shuttle box, it's not great with the running wheel, but it's still fairly impressive. And there's the term one-way avoidance, where the animal just has to go in one direction. But there's also two-way. One-way is really easy for the animal to learn. Two-way, where the animal has to go back to what was the start box to avoid the next shock is not so good. So these are different behaviors, again, from bulls. Running, the animals learn to do that very well. Turning, medium, standing still, they are not prone to that. Suggesting, response outcome. All outcomes are not the same. And there he is. There's the man, Bowles. And I saw him once at the Eastern Psychological Association, and I probably already mentioned that he had to have braces because he had polio, but brilliant researcher. And he trained a lot of brilliant researchers. And the concept of species-specific defense reactions, SSDRs, is attributable to him. And I had to write a comprehensive paper as part of my PhD process in grad school. And this is very important to me. Well, I still didn't think about evolution too much, but Bowles was definitely helping me. So species-specific defense reactions. What responses is an animal likely to do? And rats, there's research on rats and pigeons and what they're willing to do. Pigeons are very willing to flap their wings to avoid shock, but not so much to peck at keys. And if you think about their evolutionary history, if something's coming to hurt a pigeon, they rarely walk toward it and peck at it. Stigmatosis is still important to me because I study fear. And if you're ever designing a restaurant or a public space, you have to worry about stigmatosis too in humans. You like to be protected. And if you're in an open field, which in my world are circular, most researchers unfortunately use squares now. There's the open part of the open field, middle, where you're exposed. And if you're fearless, you go out there. But if you're fearful, you tend to stick by the walls. And rats have these long vibrissae and guard hairs coming out of their fur, and they like those items to touch the wall. So when you set up a situation to measure fear in animals in an open field, you often measure amount of time that they spend basically touching the walls and the amount of time that they go out into the middle. And if you're in a restaurant, you'll find people tend to populate, or a bar, they tend to populate walls so their backs are protected and they can see the rest of the room. And public spaces are often used in this way too. So stigmatosis and SSDR go together very, very nice. Now, the next piece of research is brilliant. Bowles was in Washington State, and they have the Pacific Ocean on the west, and running sort of down the middle, they have the Cascade Mountains. And then to the east of the Cascade Mountains, it gets flatter and drier. So you have moist air coming off the Pacific, which you keep out here. It comes inland, and as it comes inland, it drops its moisture, so it's very wet. And then it starts going up the Cascade Mountains. And as it goes up, it gets colder, and water is extracted from the air. And then the air goes over the mountains, and when it comes down the other side, it's very dry. So there's a unique evolutionary history to this. On one side of the mountains, animals that interact well with moisture work well. And on the eastern side of the mountains, away from the Pacific Ocean, you have animals that have evolved to deal with drier areas. Now, these deer mice live on both sides, but the mountains create a barrier so they don't interbreed very much, which is good for evolution. And on the western side, the wet side, which is easy to remember, western wet, you have weasels. And the weasels, oh my God, they love the mice. They eat the mice. The eastern side, there are no weasels because it's too dry, but you do have snakes. And these gopher snakes, they love to eat the deer mice. So Bowles and his students captured mice from these two breeding populations and bred a few generations in an environment in which there was no predator. And after a few generations, the mice had never run into predators, and they'd never run into another mouse who had run into a predator. And then they did a pretty real experiment. They exposed the mice to the predators, and they didn't do it kindly and gently. The predators were able to eat them if they wanted to. And the eastern mice were munched on by weasels pretty easily. They weren't afraid of weasels. But the western mice were afraid of weasels, and the eastern mice were afraid of snakes, and the western mice were not. Very clever. So there's, evolution at work. The animals are being modified by survival, and the animals that show fear of snakes, where there are snakes, they survive, and weasels, where there are weasels, they survive. And freezing is important here. That's a very popular measurement of fear. Rodents do this quite a bit, and they do it a lot in open fields, which I have studied, and one of my students studied this. and went off to UCLA, not the one I've already mentioned. Um, and there's a discussion there of freezing and Sidman avoidance procedure. And they would learn very readily an avoidance response of freezing, almost like they were made to, as if it was a species-specific defense reaction. But if you tried to punish freezing by shocking them, they just did not get it. They reduced their freezing a bit, but they could not suppress the freezing. So that's pretty brilliant, and that was important to me back in the day, the early 70s. And what do you do when you get shocked? Well, the first thing you tend to do is run, because you're already being injured. If you're already being injured, now is not the time to freeze. So you run a bit, and then if you're still alive, you freeze. So you get a very lawful pattern of behavior. And Bowles and Bowles, the Blanchards, and Michael Fanslow. The student I talked about before worked in Fanslow's lab. They very nice research, and Fanslow was a student of Bowles. I don't think the Blanchards had any connection with Bowles. Fanslow 1980, that's about when I came back to Scranton. Pavlovian conditioning, SSDRs, Bowles, Fanslow, and I did research on fear, sort of overlapping. As we'll see, there's some research I've done. And evolutionary history, SSDR, freezing, and you learn fear and you do what you do in fear. And one thing you tend to do in fear is freeze. And there's Michael Fanslow. Do not call him Mike. And I was doing stress-induced analgesia, and Michael Fanslow, because he's very bright and also worked with Bowles, he was doing that and a bunch of other things. I've given you a link. Here's some study that overlaps with Michael Fanslow. It deals with pain inhibition and opioids, which was used in the way it was used back in the day. That is what your body makes, and non-opioid mechanisms of stress analgesia. So Lewis Cannon and Libeskind, the journal Science, which was quite the deal. And there's the abstract inescapable foot shock, which is going to be relevant to part of this chapter. Causes profound analgesia that could be antagonized by naloxone, which can block opioids, or dexamethasone, which I hadn't thought about in a long time. I even forgot about this. That's used to treat some COVID symptoms now. When shock was delivered intermittently for 30 minutes, what I'd prefer to call prolonged shock, but not when it was delivered continuously for 3 minutes, which I would prefer to call brief shock, thus depending only on temporal characteristics. Foot shock stress appears to activate opioid or non-opioid analgesic mechanisms. Certain forms of stress may act as natural inputs to an endogenous opiate, the term I would use for drugs, analgesia system. And I probably mentioned that the non-opioid we know is related to cannabis. It's an endocannabinoid. So we overlapped with Fangelo. Now, Fangelo emphasizes opioid pain inhibition with his stress, but there's more than just the opioid. What else have we got here? We'll deal with that later. And, Fangelo talked about SSDRs and behaviors that you do at different times. If you've been injured, you pay attention to your injury, you favor it, you lick it. But if you're in the middle of trying to save your life, you can't play that game. You have to ignore your injuries. And of course, one way to ignore them is to have no pain from them. And again, he emphasizes opioid. And stress can produce profound analgesia. There's a famous story of an African explorer being attacked by a lion and picked up and shaken like a kitten and thrown on the ground. And the person at the end of it reported feeling no pain, just a sense of calm. And animals, particularly if they're attacking your neck, they're trying to break your neck. And if you have a broken neck, you don't move much. So if the attack leaves you screaming, they keep attacking you. If you make a lot of escape behaviors, they keep attacking you. But if the attack causes you to inhibit screaming, inhibit moving, and not responding to pain, the attacking animal often leaves you alone. And there was research with the foxes and ducks or swans where some percentage of the time the fox would act as if the swan or the duck were dead, go get the children for lunch, and while the fox is away, the animal would wake up and fly away. So, there's a classic figure from this book. Fear inhibits pain and other related behaviors, and it encourages freezing, fleeing. Bearing is an interesting one. Did I already go past that? But there's a weird thing that animals will do if they're in a home box where you often give them wood chips and there's an electric probe that can shock them. If they're shocked by the probe in their home box, they can't escape because they're in a box, but they will bury the probe in wood chips. And after you survive the attack, pain comes back, and you lick your wounds, you stay at home, you do other useful things. And there's Bowles and Fanslow publishing together in 1980 when I came to Scranton. Now there's the bearing behavior, and pre-encounter, post-encounter, and there's Boughton. So he was involved in this, and again, he's related to Bowles as well. And then there's a general discussion of cognitive factors and measurements of fear, and how much fear is the animal really experiencing in a situation that's novel or that they've done before. And there's, freezing, fleeing, bearing again, and SSDRs and more fear. And Ledoux, who I think we've seen before, is a huge researcher in the field of fear, does a lot of important neuroanatomy. I saw a talk he gave at neuroscience, the Society for Neuroscience meeting, and I never thought about the amygdala the same way. Again, after that talk, he's brilliant, and he has written books for popular consumption. And I'm sorry, I'm a little confused because I'm teaching another course that's dealing with some of this, but Ledoux is a popularizer of neuroscience. And if you're ever in New York City, his band used to play at local bars. I own this recording, and it looks like northeastern Pennsylvania to me.
While I was fearing it came, but with less of the fear, because fearing it so long had almost made it dear. There is a fitting dismay, an appropriate despair. 'Tis harder knowing that fear is due than knowing it is here. The waiting is.
I've always wanted to have a student work in his lab, but it never happened. He's an interesting guy. I'd love to see his band in action. And he changed my life in terms of what the amygdala is up to. And if we were in behavioral neuroscience, oh my, we would spend a lot of time on that. And there's discussions here of feedback and multiple responses, and you get natural feedback, you can have artificial feedback. Agoraphobics, bringing a pill bottle with them when you go out, knowing that you have something you can take if you need to. And there's a discussion of obsessive compulsive people having coping stimuli to reduce fear as well. And there's human research involving basically GSR and animals that learn that they are animals, humans, which are animals, that they can avoid the fear, the aversive stimulus. They're pretty calm, and there's not a lot of signs of autonomic arousal and fear and anxiety. But if they don't figure it out, there is. And there's humans and computer screens and two different responses, and there's a picture of it. And shock expectancy, they expect shock after R2, but R2 is still inhibited the expectancy when it's combined with the CS. it looks like occasion setting, which should make you go back and look something up. And that's discussed in that section. And now stuff I really do care about. Stephen Mayer came from the UPenn, and he was doing stuff a little bit earlier than my graduate training, but I was doing stress-induced analgesia, and they were doing learned helplessness. And in both cases, animals were being exposed to shock. And I became convinced that part of their learned helplessness was what I was studying with my inescapable shock. And, in my lab, you shocked animals and it inhibited pain. In their lab, you shocked animals and they didn't worry about pain, but the animals didn't, they developed learned helplessness. And I went to Eastern Psychological. I don't think it was the meeting that I met Bowles, but I was snooping around the Penn labs trying to figure out if they knew what, did they know what I knew? And somebody told me they did. And because of that, I did not follow that path of research. It turns out they didn't. But Steve Mayer, many years later, did do research that was relevant to this. And, Seligman and Mayer, there's there's a few concepts here that you need to deal with. One of them is yoking, which I thought was common English, but it's not. So if you played Oregon Trail, and you're probably too young to have done that, that's yoking. So two animals wouldn't yoke, and where one animal goes, so too does the other. So in research here, we have yoked controls. And actually, it's not two yoked conditions, it's three yoked conditions, as we will see. And here's a picture of the triadic design apparatus. I built some of this, but not the whole deal. So you go to your behavioral equipment store and you buy these chambers. And they're sound attenuated, so nobody can hear what's going on next door. If you look at this one, you can see there's a wheel. Looks like a little water wheel. So the animal is held by their tail. It's clamped in here gently with foam or taped, and it's connected to electric leads. How yoked are they? They are so yoked that if you are in one of the shock conditions, the same shock wire goes to two animals. So they get exactly the same shock at exactly the same time. There's also a control that doesn't get shocked. But in one scenario, if they get shocked and they spin that wheel, the shock gets turned off. And it doesn't just get turned off for them, it gets turned off for their partner, their yoked control. And this guy doesn't get shocked. So it's classic research, very relevant to, whoa, didn't mean it. Here's a picture of an individual chamber. So there's the wheel. You don't get shocked from the wheel, but it does use the same kind of shock bars. The animal's body is in here, but the tail comes out onto this piece of plastic where the animal is restrained. They really can't go anywhere. And then the electric leads are connected to the tail if the animal is destined. Well, they're connected regardless, but they're not activated if the animal doesn't get shocked. So this is very important and very clever research. So phase one, you have escapable shock. Phase two, yoked and escapable. Phase one, yoked and escapable for the inescapable group, and the no shock group, they don't get shocked. And then in phase two, they get escape training. And you can see that the animals who had escapable shock or no shock, they learned to spin that wheel very well. Whereas the animals who had experienced inescapable shock, which, by the way, I believe produces analgesia, they don't respond all that well. They did some of this research with dogs and shuttle boxes, but that did not get them good press. And the animals would be inescapably shocked if they were in that group. And there was a barrier between the two sides of the shock box. And then the barrier would be taken down, and animals in the inescapable shock condition often would not shuttle at all. They required pretty much therapy to get them to shuttle. We don't really do that anymore to dogs. Mayer and Watkins, they were really important to me. They did stress-induced analgesia. We did stress-induced analgesia. They have a real research empire in Colorado. They are machines. And somewhere in here, my lab comes up. So there's the learned helplessness hypothesis and learned helplessness effect. And you also have learned irrelevance. And this is thought to be potentially important for depression in humans. And I'm trying to see my people, but there's an article in here with there we go, Sherman, Mayer, Sherman, Lewis, Terman, and Libeskind. And I worked with Sherman, Lewis, Terman, and Libeskind, not Steve Mayer. But finally, in 1983, well after I came to Scranton, they finally put the two fields together. And our long stress analgesia, the animals had to learn that they couldn't escape. And if they learned they couldn't escape, in Steve Mayer's world, they were helpless. And they also developed profound opioid based analgesia. So the two fields belong together. It took, forever, almost a decade, to get them together. And Miner, I didn't look for that, but I used to play softball with him. Steve Mayer, Michael Fanslow came to UCLA. John Garcia was at UCLA. Miner came to UCLA, and we used to play softball every Friday. And he did some interesting research on learned helplessness and stress, and he made some important and real contributions. So this is Miner, and you have backward conditioning again, and that's an interesting discussion, and it's important. and he likes softball. There's Rescorla, comes up again in the summary. And then we move into parallels in appetitive behavior. And the Breland and Breland, they they wanted to make money. They wanted to train animals to perform in public, and you'd put in a quarter, and the chicken would play ping pong, and the raccoon or the pig would put the coin in the piggy bank. But it turned out to be important because of instinctive drift. The animals would do what you wanted them to do, but then something happened and you lost them. And when I was you, all psychology majors had to have a rat and train it to press levers and pull chains and do a lot of other things. And for extra credit, you could have the animal do additional things. And one of them was to play basketball, where they'd have to pick up a marble and drop it through a hoop, and then they'd get the reinforcement. But what I remember vividly, although I don't think I knew about the Braylons at the time, was we had to train them. You took a pipe, like a pot pie tin, punched a hole in it, and you required the animal to pick up the marble and drop it through the hole. And if they dropped it through the hole, they got their pellet, and you got your extra credit. But we quickly discovered that once they started doing that, you had to get the faculty member over there immediately to give you credit, because if you continued to train them, they wouldn't let go of the marble. They started treating the marble as if it was food, and rats do not drop food down a hole. So they would perform beautifully. If you were lucky, you would get your credit. If you continue to train them, they became Breland and Breland's animals. It was very frustrating for the college students. And there's a nice discussion of that and superstition, which came up earlier in the textbook. And here we have what pigeons do and what rats do as time passes after food has been delivered. And they do different things. And, some of what we considered to be random superstitious behavior really was not. They're not SSDRs, but they're related. Terminal behavior, yes. Important. And Skinner interim behaviors, that's related to that. Adjunctive behaviors, I became pretty fascinated with this. Schedule-induced polydipsia. This really intrigued me. So animals working for food pellets, if you gave them unlimited access to water, they drank a lot. And you may see this in your studying behavior. Sometimes as you're studying, the amount of fluids you intake goes way up. And it's schedule-induced polydipsia. And there's pigeons attacking pigeons. This is not my friend's research with post-reinforcement pauses on fixed ratio schedules. But pigeons will do that. Rats will run on wheels. Displacement activities. Birds conflicted over acting aggressively will sometimes approach a target bird and then, for no good reason, just stop and start pecking at the ground as if there's food there. So it's complicated and interesting, and certainly relevant to Bowles' stuff. And Brown and Jenkins, that's we've dealt with that earlier. That's important. And auto maintenance is relevant. Negative auto maintenance, even if you try to punish sign tracking, the animal cannot help pecking. They are helpless before the situation. And more Braylon, more drinking, and displacement activities or activities near different stimuli, punishment, and now we're getting into the S's, SOs and ROs, and they're both important. And behavior modification was a popular term back in the day. It has negative connotations now, but the punishment Skinner didn't like, and he, almost magically believed in positive reinforcement, which definitely does work. But if you think about your daily lives, how much of your daily life is controlled by punishment? And the answer is a lot. And it doesn't freak you out. I mean, there's a chair in the middle of the room. You walk around it. It's not a big deal. So punishment is worth studying, and it's definitely worth understanding. And I'm going to give you a lecture next time on punishment. And there's a nice discussion there of punished and non-punished behaviors, pushing and pulling a lever, and punishment can affect one behavior and not another. And there's more demonstration of the ability of punishment to control behavior. Don't believe that punishment is bad. Punishment done badly is bad, but we evolved to deal with punishment very nicely. And boy, we're going back to Tolman again, 1946. So this really is the whole chapter. What does it mean? Species specific, biology matters, but certainly learning matters too. And cognitive analysis, there are the diagrams we saw from earlier in the book, and there's the S and the O and the R, and occasion setting and habit, where animals do things without thinking about it. And if you've learned to avoid something, you don't think about it. You're not afraid. You don't scream, oh my God, there's a chair in the middle of the room. I might walk into it. You just walk around it. So various types of learning that can occur in any instrumental learning situation. And it all comes together. This is quite the chapter. And knowledge of the response outcome, reinforcer devaluation, that's been dealt with before. And you're working for food pellets or sucrose, and you devalue one and not the other, either by poison avoidance or satiation. and what you expect tends to occur. The Hetherington, I knew Hetherington, not that one. Sensory specific satiety. So good reason. And there's the child, and they're using cartoons, and they satiate the child on one cartoon until the kid gets sick of it, and therefore they devalued it, and they don't ask to see what they find devalued. They go for the other cartoon. The intent of learning, we saw this before too, that the animals have to experience the food they eat affecting hunger. So this is a nice review. And this is using a drug that reduces nausea. And during retasting, the rat could experience the yuck reaction, but the drug suppressed the drug reaction. They tended to stay away from the one that produced the outcome associated with yuck. But again, they have to learn that the drug does something. Simply taking the drug doesn't do it. These results suggest that operant learning involves some very subtle learning processes. There are three things to remember. First, the organism associates the operant behavior with the outcome. So response outcome. Second, the organism decides what to do based on how it currently values the reinforcer associated with the action. And third, value is assigned through incentive learning. For this process to take place, the animal must experience the reinforcer, potentially in the appropriate motivational state, to know how much the animal likes it in that state. All three processes come into play in operant and instrumental conditioning. This is really everything. ROSO, size of the O, lever pressing, electric shock. You got some blocking going on here. This kind of result suggests that factors we think of as important for SO learning, that is surprise, may be important for operant learning too. And Catania, I owned a book by him back in the day. And there's the difference between ratio schedules and interval schedules. Ratio schedules engender true action outcome learning, whereas interval schedules may generate habit. I'll remember that in a ratio schedule, and you should remember because we have a comprehensive final, responding rate of reinforcement in a partial reinforcement schedule is related to rate of responding. The more you respond, the more you get, whereas interval schedules are pretty dissociated. And there's a discussion of, and Peter Holland is in here, and we've mentioned him before, the student who went on to work with Michael Fanslow did a summer with Holland, and he definitely helped her get into UCLA. And she did really good work on freezing and fear. And Peter Holland has run many very sophisticated experiments suggesting that rats encode a rich representation of the US during Pavlovian conditioning. For this author to say that somebody has sophisticated experiments, you can just imagine. So SD and S delta come up here again. noise and pellets and sucrose and chain pulling. They like to pull chains. Those chains, by the way, are very much like what used to be in cumulative recorders. So there's effects of responses in minutes over trials where you have treatment with the same stimulus or a different stimulus or baseline, and the final test is done during extinction. Light and noise both increase the rate of response that have been associated with the same outcome, but not the different outcome. So, and you can see the melding here between classical conditioning and operant conditioning. And there's Rescorla and Solomon, 1967, Konorsky. These are really, really classic studies. In the is it SO, is it RO, is it both? The odds are almost always that it's both. The SD is more than just Pavlovian. It provides information about RO. That is, the SD truly sets the occasion setting for the RO relationship and another relationship. And then to make things more complicated, you have S, quantity RO, occasion setting, which we've dealt with before in Brown and Jenkins, and auto shaping. And if reinforcers are presented with the same probability in the presence and absence of a CS, CS won't be treated as a signal for outcome. If, however, CS signals that a response is now required to earn the reinforcer, the animal will learn to respond during CS. So that's very cute. And there's relevant research down below with noise and light, and whether you're dealing with response 1 or response 2. And you can see there's a big difference between the light and noise conditions for both response 1 and 2. For noise, response 1 goes down, and response 2 goes up. So, and that involves devaluing with illness. And there's more doing the same kinds of things with 2 responses and lithium chloride. And Boughton, your author, the results of these experiments require that we accept that rats have a fairly sophisticated knowledge of various contingencies. There can be no question that more is going on in operant conditioning than merely stamping in a response. So again, the debate between classic Skinnerianism and cognitive is definitely part of modern learning theory. And there's Rescorla in 1991, and habit learning with, again, we're dealing with devalued reinforcers, and the animals will do some things out of habit, and we do that. So it's complicated. There's ROSO and old style habit learning. The civilization advances by extending the number of operations which we can perform without thinking about them. Habit. A lot of what we do is habit, and habit largely occurs without intense emotions. So here we have 2, 5, or 20 sessions of learning and devaluation and not devaluation. And it's Clever Holland again. And you can see with 20 sessions, uh, devaluation doesn't do a lot. You've shifted from, arguably motivated behavior to habit behavior, which doesn't feel the effects of devaluation. And M&Ms and Fritos, it points out that you don't get them, you get them later. And it's a VI schedule. VI is very popular. The with the animal research, and then there's again, chain pulling and lever pressing. The having multiple RO outcomes, it may encourage the animal to maintain attention to its different behaviors, so they can't rely as much on habit. If there's differences, they have to pay attention. And then reinforcement learning models. These models attempt to capture the basics of instrumental learning by assuming that in a given situation, the organism will make a response depending on how strongly it's associated with the reinforcer. And the association is updated over time with a mathematical equation that you are spared from learning that's closely related to Rescorla-Wagner. But they can't explain devaluation. So many gaps still remain. The development of reinforcement learning models and our understanding of habit learning is still a work in progress. Which, of course, if this is what you're devoting your life to, you're very happy about. And we're back to plus mazes and starting from one location, and you learn the response, or do you learn the orientation in space? And the bottom line is it depends. And it depends on training. And the extended training thus converted the rat's behavior from goal or place-directed activity to a kind of SR habit. You just turn in a certain direction. And hippocampus rears its head here. And remember, there are place learning cells in there, which are important if you're paying attention to place, but not if you simply have a left-right habit. And there we are dealing with the caudate. And McGaw is a big name in learning theory, not unlike Ledoux. And lesioning the hippocampus deals with reduces responding based on spatial learning, but not response learning, whereas caudate nucleus lesions do response learning and not so much spatial. So the brain does show up here. Whoops. It is important. Yeah, there we go. So there's your elevated plus maze and hippocampus inactivated. Oh, and they did this with, I think, lidocaine. They didn't blow it up. Caudate nucleus inactivated. You can see there's there's a big difference potentially between day 8 and day 10, and the inactivating the hippocampus doesn't do much to response, but inactivating the caudate definitely does. So that's very clever research, and that's McGaw, and he is clever, very clever. And finally, there is now quite a bit of research that seems to separate place and habit learning, as we just saw, complements research correlating different brain areas with other forms of actions and habits assessed by reinforcer devaluation. Research in behavioral neuroscience is consistent with the purely behavioral research reviewed in this chapter in exploring the roles of SO, SRO, and SR, and incentive learning processes in instrumental learning. So I'm a little surprised that the book doesn't end with more of a crescendo, like a rim shot, drum roll, please. It just ends. And I know I always feel like there's more to come, but this is the end. And if you calmly go through this chapter and the book, you can see how what used to look like independent elements that we were learning one at a time integrate a lot better than we probably expected early on. I think Boughton has done a good job. This is an extremely thoughtful textbook. It is used at the graduate level because it is so thoughtful and deals with so much primary research. I hope you've enjoyed it. I hope it's interested you. I hope it's interested you in learning theory and the importance of this to clinical fields of practice. I'll deal with a little bit of that in my lecture for next week. Thanks for tuning in.